In part one of this lesson, you took a look at the definition of mass and how mass was how much matter is packed into a substance, how the atoms pack close together or not so close together, how the atoms can be really, really big or really, really small, and how really large samples of a substance are going to have more atoms than really small samples of substances. Those are the things that determine the mass of a substance. In this part of the lesson, we're going to take a look at a related term, and that is the term weight. Weight and mass are very closely related to one another, but they are not exactly the same thing. We'll get into why some people think that they are the same thing and why sometimes in science even we use mass and weight interchangeably, but it's very important that you understand the difference between mass and weight. Let's get started looking at the definition of weight. Scientifically, we say that weight is how hard gravity pulls on the mass of a substance. Do you see why weight isn't the same thing as mass? It depends on mass, but it has to do with something that mass didn't take into account. Weight has to do with gravity. In science, we usually measure weight in a unit called newtons. Notice that that's different from the gram-derived units that we use to measure mass, kilograms, milligrams, or grams themselves. Newtons are different because they measure something different. They measure how hard gravity pulls on an object. Now, in our everyday lives, we're probably way more used to measuring weight than we are to measuring mass. Anytime you step on a scale, what you're actually measuring is how hard gravity is pulling down on your mass. But here's the thing that makes mass and weight confusing. The more mass an object has, the more matter and atoms are packed into that object, the more weight that object has also. It's almost as if we're talking about the exact same thing when we talk about mass and weight. Because here on Earth, as an object's mass increases, its weight increases at the exact same rate. But there's one key difference between mass and weight, and you have to go to outer space, to other planets and other places to actually see this difference in effect. And we've actually done this before when we had human beings travel to the moon. On the moon, astronauts got to experience the difference between mass and weight. Now here's the deal. When an object from Earth, let's say a person like an astronaut, goes from the Earth to somewhere else in space, like another object, the moon, the mass of that object stays exactly the same. The mass of these astronauts didn't change just because they went from the Earth to the moon. The amount of matter packed in them wouldn't change, right? Logically, the amount of matter packed into an object is going to stay the same regardless of where it is in the universe. However, gravity did change. And because the gravity changed on the moon, astronauts had to move a lot differently. They could jump a lot higher, and they experienced gravity's pull on their mass a lot differently. In fact, this astronaut jumped and fell over because he wasn't used to the difference between his weight on the Earth compared to his weight on the moon. Weight changes depending on how much gravity there is, whereas mass, the amount of matter packed into an object, stays exactly the same. So remember, weight is how hard gravity pulls on an object or a substance, and it's actually gravity pulling on the mass. The more mass an object has, the more weight it's going to have. So they're related to each other. But if something goes from the Earth to a different place in space, to a different planet, to the moon, its mass is going to stay the same, but the object's weight is going to change based on gravity.